so I am here today kind of wearing an old hat and talking for the folks who I work for now. So I'm going to be talking a little bit about climate data and then how you can integrate climate data into natural resources. I have an example. It's from the lower Rio Grande, so you'll just have to go with me on that one. It's from Big Bend, and we're just going to go with that. So first we're going to talk a little bit about finding future climate data, where you can find it, questions you should be asking yourself, etc. How to use those data responsibly and intelligently in a way that is scientifically defensible. I'm not going to go into a ton of detail on that, but I mean the detail could fill entire courses. And then I'll talk about the example of applying climate data to management plans. I'll try to stop talking so fast. Okay, so since I've done a fair bit of this myself, whenever I am looking for future climate data, I kind of start with my questions, and I kind of step through this in a semi-logical manner. So I love that they've all turned into question one. That's fantastic. They're all equally important. First, what management challenge are you dealing with? That's always an important one to know. What questions specifically do you need to answer to make decisions about either the challenge that you're facing or potentially even an opportunity? So management opportunities come up as well. They're not all just challenges. What spatial scale are you working in? And I'll get into that a little more, but spatial scale is really important because not all models work at all spatial scales. And then finally, what time frame do you need information for? Because that's gonna kind of tell you what climate data you can use. Nope. There we go. So first of all, what management challenge are you dealing with? This might be a question are you managing for endangered species habitat? That's one that this program deals with a lot. So food, shelter, water availability. Managing for plant biodiversity is one that I deal with a lot because I come from restoration ecology and botany. Managing for structural diversity in a plant community, obviously really important to things like bird species or insects. Managing for wildfire risk, of course we've talked about that today. Or managing from transitions from one ecosystem to another. So we've also talked a little bit about that today. I'm going to step through this using this as the example, managing for structural diversity in a plant community, just because that's where my brain tends to work. So second question that I ask myself is, what question do I need to make decisions about this challenge or opportunity, in this case related to plant community structure? And in terms of structure, I'm thinking both vertical structure, so little tiny flowers all the way up to big trees and kind of the heterogeneity in that, but also structure of different types of plants to each other. So how many of the little flowers, how many of the trees, that kind of thing. So how will temperatures affect the different species in the community? Is it going to be really good for this one species of tree and really bad for the other? We talk a lot about how cottonwoods respond to temperature and precipitation versus Russian olives or salt cedar. How is precipitation going to change over the course of the year? So something like when the rain falls or if it falls as snow might be important. What's going to happen to the growing season? Is it going to get longer, shorter, hotter, drier? What's going to happen? One we've talked about today is invasive species, and that's the one I just enjoy talking about. So how are temperature and precipitation going to affect invasive species versus your native species? And then what plants will be well suited to the area in the future? Andrew just mentioned that as well. So, not what's here now is probably not going to be what's suitable into the future, and that's going to affect your plant community structure. And then after that, you kind of have to decide what spatial scale you're making that management decision at. So are you making the decision, in this case, for an entire reach, for the entire Albuquerque reach? Or are you doing it for a sub-reach or a little area, the outflow area? are you doing it for like a little bit of Tingley Beach or an entire wildlife refuge? So you kind of need to know what scale you're making these decisions on, because that's going to impact what climate data you can use or want to use. And if you're really, really crazy, you can make decisions for the entire Rio Grande, and then you can get a headache or other terrible things. You need a group to make those decisions. And then finally, what future time frame are you looking at? So are you looking, this is in both how far into the future are you making the decision and how do you want to chunk that time? So do you want future climate information for annual decisions or for like 5-year or seasonal? And then are you looking at like so climate scientists a lot of time talk about mid to late century, so you can have mid-century or late century, and in a lot of cases very little in between, you get one or the other, so pick, do you want before 2050 or after 2050? Okay, here you go. If, however, you are thinking about next year, you're not looking for climate, you're looking for weather. I just wanted to put that in there because sometimes people get the weather and climate confused, and I just have to say it. So if you're looking for next year, you're probably not looking for climate, you're probably looking for weather, and that's a whole different set of like data that do totally exist out there. It's just a lot of times you're not going to find them in the same places as the climate data. You find that more on like National Weather Service or something like that. Okay, so I intended this to also be useful as far as y'all will be able to access it afterwards and be able to have this as a reference. I've included just 4 potential sources for climate data, and I included them because I've used them or people I know have or do use them or are responsible for them. So again with the bullets. So the first one is the US Climate Resilience Toolkit, the Climate Explorer. Some of you may be familiar with it. All of these are quite user-friendly. Either you just go to the page and like it makes sense, or they have really good user guides, or they have people who are easy to contact to help you with them. So the spatial resolution, that means like, yeah, so how big 1 pixel is. That one is 7 kilometers, so fairly small, and it has both seasonal and annual time steps, so you can get it for different seasons or for different years. But that's it. You're not going to get monthly. The USGS National Climate Change Viewer, however, that is a smaller spatial resolution, so even tinier pixels, and then they also include monthly time steps. So you want to know like about January in the year 2075, they can give you an estimate. It's going to be an estimate. They're not giving you the exact weather as it's going to appear in January in the year 2075. They're running models and then estimating it. 2 more are the Climate Mapper from the Climate Toolbox. And that one will actually allow you to make these really cool graphs. You'll see a couple of them later for specific things that you might be interested in, like precipitation on a seasonal basis, or, oh gosh, it's all manner of things. Growing season, growing degree days, and they're always adding new things. So that one gets updated so regularly that it's honestly kind of amazing to me. And then finally, I have to put this one in here. For our region specifically, the South Central Climate Adaptation Science Center has downscaled projections, and they make those available to anyone. You can download some of them on their website. That's what's linked there. You can also email them and ask for ones that you don't see on the website, and sometimes they will have those that they can give you. And they can customize them in all kinds of ways. People who know me from before know I used to work for those people, but I can tell you who to contact if you need to. But their website will also be in that link. Okay, so some things to consider when you're using future climate data, because not all models are the same, not all climate data is, are, whatever, I use it interchangeably, are the same. So first of all, which models are being used and what those models do well or don't do well. Some models are really good at dealing with like mountains that exist, or they're really good with dealing with, I don't know, like weird stuff like water vapor in the air or clouds or, you know, any manner of things. The downscaling methods that are being used, if there are any, so pretty much any regional kind of model that you're looking at pictures of is going to have been downscaled from one of the like panel on climate change, you know, groups of models. They do that so that it's like locally relevant. Otherwise you have these huge pixels that cover like the entire city of Albuquerque and then some. That's like not super helpful when you're trying to make decisions about a refuge that's a fraction of the size of the city. The data availability for your purpose, so the best model in the world isn't gonna matter to you if they don't have the data that you need. And then finally, the appropriateness, if that's a word, of the data for your specific use. So some things the data can be used for, and there are things that the data should not. So like you could technically use them, but you should not. And if a climate scientist then gets a hold of your results, they're gonna be like, hey, you actually shouldn't have done this. The good news, however, is that you don't have to have the answer to all of these yourselves. I don't have the answer to these myself. When I need to ask these questions, I go, hello. I go ask one of these people. So there are 3 kind of regional resources that you hear about if you talk about climate services a lot. It's the South Central Climate Adaptation Science Center, which I will hear on out call to CASC if I have to say it again. There's the Southwest Climate Hub. They're down in Las Cruces, and they focus mostly on agriculture. The CASC focuses mostly on natural resources and cultural resources. And then the Southern Climate Impacts Planning Program is primarily communities, so including urban, suburban, and actually rural communities as well. They're kind of more like the, if you're talking about like water supply in rural areas or that kind of thing, utilities, that sort of level of stuff. In reality, all 3 of those kind of talk with each other quite a bit, so chances are if you get to the wrong person, they're gonna tell you to go talk to someone else. Don't be afraid to ask these people questions. That's literally their job. Also, there are other climate services organizations, smaller ones, that are much more specific that I could not get an exhaustive list of. If you search for climate services and like whatever you're concerned about, you have a pretty good chance of finding them on Google. Within organization, climate scientists or climate specialists, so like, for example, I know Fish and Wildlife Service, they have their climate coordinators. There tend to be climate specialists or climate scientists or someone who understands something about climate models within a lot of organizations because this is becoming such a thing that we now have to worry about. So it's always worth looking within your own organization. Those people might be easier for you to get a hold of. I'm talking so fast. Okay. Excuse me. So I'm going to talk a little bit about once you have all of those data, what is one kind of framework that you can use to apply this. Out the gate, so I use the word scenario and then expect for some reason, like for people to understand, you know, just from context, clearly, which scenario I mean, which is unreasonable. So in talking about scenario planning, I'm not talking about climate change scenarios. I'm talking about like the framework that's in business and in other things where you come up with your own scenarios and then you plan around them. There's also climate change scenarios. I will do my level best not to use those 2 interchangeably, but if I do, feel free to raise your hand and be like, which scenario are you talking about? And I'll clarify. So this was a concept that was developed at the National Park Service. It's climate futures scenario planning. So it's scenario planning with climate futures. And it's a framework for understanding the range of plausible future climates. So we're not talking like some crazy future climate that's completely outside the realm of plausibility. We're talking about plausible climate futures only. And then exploring options for how you can adapt within the range of those plausible climate futures for like a given problem. So typically you don't just try to talk about how you would adapt everything. And in this case, in Big Bend, they were looking at park infrastructure to provide water. If you've ever been, they get all their water up in the Chisos Basin through like a couple pipelines. It may only be one pipeline. And they're like gonna have issues with that because it's quite old. And so they're trying to figure out with increased park visitorship, how are they gonna deal with this water problem and climate change? And so that was their specific scenario. But within this room, there would be loads of other scenarios. The first step out of this is that you spit out a graph like this from somewhere like, I don't know, the Climate Mapper. It spit out this graph. It and Angela spit out this graph. This is all based on work that other people have done. I want to be clear about that. It's not me. So you generate this using a bunch of different climate models, and you end up with this like kind of scattered around vision of what the future might be. In this case, we have change in January to December mean temperature along the bottom here, from 1.25 all the way up to 4.5 degrees Celsius. And then along this side, we have change in the precipitation in millimeters, all the way from a loss of 80 to a gain of 40. So pretty wide there. And then the climate models spit out all of these. One thing I want to be sure to remind you is that all of those are plausible climate futures. So again, these are not outside the realm of plausibility. We are dealing, all of the little dots on here are equally plausible. None of them are more plausible than the other. That was hard in my brain for me to get, and so that's why I keep repeating it. So then, in the interest of planning for these, different scenarios and having plans that can be applied to the widest range of possible futures, you pick like kind of two extremes. So in this case, it would have been one that represented quite a significant loss of precipitation. This would be about minus 22% or minus 60 millimeters of precipitation, yearly precipitation, with a coincident increase of about 4 degrees Celsius in temperature. So way hotter and quite a bit drier, 20% drier. And then on the other end here, equally plausible, is still an increase in temperature, but precipitation is one of those weird variables that like climate scientists have issues with it because it's kind of hard to predict in future models. So in this case, it could be an increase of 10% precipitation, so an increase of about 20 millimeters. And so when you pick those two things on either end, what you're doing is you're working within a space where almost you've kind of captured the full variability of what's possible, which means the plans you make that will fit either of those are plans that are going to fit like a different change. Say anything hardly changes at all. Say we end up like right in here. Well, congratulations, the plans you made for these two things, they're kind of also going to work for whatever's in the middle. So it's a really powerful tool for kind of bending your brain around your various options. So the second step is using those, wrong way, Feldman, is using those divergent futures to then figure out what's going to happen to the variable that you're interested in. I apologize for committing the cardinal sin of like, why did I even put these on here? So in this case, like this would be fire danger. So you're seeing, this is summer fire danger, increasing significantly under this future scenario. On this one is the soil moisture under this like kind of we get more precipitation scenario. And what you're seeing is the winter moisture is this brown bar. It's decreasing, but you can see what's happening to your soil moisture. So you start lining up these future climate, I'm going to use that word, climate scenario. It's the unofficial climate scenario. You start lining those up with what's actually going to happen to the things you care about. Precipitation, stream flow, I don't know, spring runoff, all these kinds of things. And then finally, you get to the part where you start connecting those things then down to like, how are you going to manage for that? So say stream flow, or okay, we'll use fire danger. Say fire danger is going to increase. How are you going to measure to meet an objective? In the Big Bend case, say all of your precipitation is going to increase, but you're still going to get loads of visitors a year. So how are you going to manage that water source so that you can meet the demands of the ecosystem and the humans in the park? I mean, like, there are people that live at Big Bend who need to be able to drink water, and it's not going to fall from the sky. So you start connecting that to the things you're actually having to make management decisions on. And then you identify potential management options. As long as you're working within that plausible space, right? You're identifying management options that will work for the whole range of potential futures. This is also a really good way to identify where you need additional data. So like, if you need to know how something is going to change, but those data aren't out there, maybe you should go see if you can start collecting them now, rather than in 30 years, you get there and you're like, oh my God, we needed this data 30 years ago, like from 30 years ago, and we have nothing. So it also gives you an idea of where you're going to be heading and what data you're going to need to start making these decisions. I included a cute photo of a New Mexico meadow jumping mouse and a Pecos sunflower because I feel they get less attention and I love them. So you know, maybe you need to know how to manage habitat for the jumping mouse. Maybe they have I don't know that much about them. Maybe they have very, very strict needs for like the grasses that they build burrows in. You need to be able to make decisions about that. If you don't have the data, start collecting it now. And the takeaway of this whole process is that by planning for the full range of those admittedly extreme, plausible futures, you're hitting everything in between as well. You're coming up with management decisions that while you may not be able to use them in the precise, like language that you made them, you can build off of them to come up with other management decisions. And it gives you an idea of personnel, knowledge, resources, things you will need. It lays the groundwork for incorporating climate change information into decision-making processes. So this is almost like, I don't want to like make it sound demeaning, but it's almost like making decisions with training wheels on. So it gives you a framework to work within so that when you actually have to hit the ground with stuff like this, you've already had that practice. You already have kind of like the process in your brain of like, okay, here's how I step through this. It's not like making these decisions is super intimidating the first, 50, 100 times you come up against it, but the more you kind of work through that process, the more comfortable you get with it, right? So get comfortable with it before you have to. And then finally, it becomes a process for developing these climate adaptation strategies before you need to use them, which means you're working proactively rather than reactively, which is a huge challenge, right? In natural resources management is sometimes being able to like get ahead of what you're, like the decisions you're trying to make. I know like by luck, whatever, force, we often end up making decisions reactively. This is one way to like kind of try to move into that more proactive space. So that you can be a lot better prepared when the time comes. And that's all I have. That is my email address. If anyone needs to email me, feel free. I can point you to people who can help you. Does anyone have questions? Sharon has a question.
I just have a comment because you mentioned.
Yeah, so I don't know if everyone could hear Sharon, but she was reminding me that in addition to SCIP, which is it's by NOAA, they used to be called the Regional Integrated Science and Assessment, RISAs. You may have heard that. They're now called CAPS, which stands for Climate something, Anyway, if you search NOAA CAPS, all capital letters, you'll find them. The other one that serves New Mexico is called CLEMAS, which someone definitely mentioned earlier. I remember CLEMAS being up there. It was Andrew, yeah. So they're also an option. And she was saying you can also contact her or talk to her afterwards if you need to get in touch with the Climate Adaptation Science Center folks.